Hey guys, welcome back to Home Built, and this week we are back on the Frankenhauler and starting to build our sliding tray. All right, guys, welcome back. And it's been a couple of weeks since I've been working on the Frankenhauler. Last week, I was on the Ferrari. I finally got Mrs. Jeff to drive it, which some of you saw, and the comments were quite amusing. The Ferrari is going well. Actually, I did mention in that video that I was having issues with the suspension, and then I actually gave it a pretty reasonable wheel alignment on the weekend, and realised the caster was all over the place, ops different on either side, and the toe was all out. And yeah, now I've actually done that, and with the adjustment I did on the rear end, the handling is actually really good. So that is all working. I don't have to change that training arm setup. I had to talk to Colin Byrne, who sort of helped me out with that setup in the first place, who has one of these that he's raced very successfully in different Targa events, and his father's car has the same setup. And yeah, and he's had no issues with that at all, and it all handles great. And yeah, and now it's all working the way it should. So it's got that nice low roll center. The top is not affecting the roll center because it actually can slide side to side. It's really good. But if you missed that last video where Mrs. Jeff drives the car, I'll put a link up above so you can catch up. And like always, do those things, subscribe, and definitely comment. That stuff really does help out the crazy algorithm. So, as far as the tray goes, well, yeah, we are at the end where I need to start actually building something that we can stick on the back of here and can actually slide on and off. So. First things first, I think we need to start mounting up some of the wiring stuff up here so we can cycle everything and get that all working the way it's supposed to.
So back into it for another week, and first of all I'm going to get through and grease up all of these grease nipples on all of these hinge points.
I've just gone through and greased up all of these little grease nipples while I think of it, and now it's time to start mounting up this control box for the winch, see if I can tuck it away somewhere and make it nice and neat. So let's do that.
So I thought it was a good idea to actually mount up this control box rather than just dragging it up and down all the time. And that means pulling it apart and then looking at where the mounting points are and trying to make a better way to mount it. As you can see here, I'm using my favorite method to put in captive nuts into a solid plate, which is using flange nuts and with a hole that is just big enough for the nut to go through, but the flange catches on. You can weld the flange and have a captive nut.
All right, so we have the power unit mounted. Now, I haven't got the wiring done. The wiring is something I'm going to move on with later. Like I mentioned before, I have the issue that getting the cables to the battery for the winch, because the winch is going up very high. Now, in theory, you could run cables from the battery all the way down to the hinges and then back up to the winch. So then you wouldn't have articulation issues. The trouble is that the longer you make the cables, the more resistance, the bigger the cables need to be, and it's a bigger issue. So it's better to keep the cables as short as possible for something like a winch. There are the plastic guide tracks that you get that curl around and would work well for the sliding bed, but in this case, because we're going sort of straight up and down, they're going to sort of curl around into a weird shape when they come down. What I'm thinking is a simpler version of that. All I really need is I'm going to make, imagine these are bits of conduit, I'm going to make some sort of probably plastic conduit and make up some 3D printed joins for it. And as the tray goes up, these are going to go up like this, far enough so that they don't lock out. They'll just be on an angle and they'll be able to travel up and down through a set path and have the wires in them. So that's the plan I'm going to use on powering the winch itself. There were suggestions I could put the winch down the bottom and run up and run a cable, but that puts that triangulation puts a lot of load onto the tray and way more force through than necessary, rather than a straight pull is a lot less stress. So yes, I could have done that, but I'm not going to do it. So for the tray, this is something that has been that I keep waking up in the middle of the night and having different ideas and trying to work out exactly how I'm going to do it. The tray on the top, now this is where it starts getting difficult. What I've done to now is the really easy bit. Getting this tray and everything to work the way I want it to is quite a complex task because there's lots of little things that you need to think about. So I'm going to be using this heavy angle as basically the guides to slide along the top of these slides. And this is what the tray is going to be built onto, is onto a couple of really big bits of angle. This inner edge, they're just going to be running along the edge of the metal. They will wear it out slightly, exactly the same as what is on the video I showed you. That's just got like square tubing running against square tubing. I will grease it up, etc. And yeah, I'm not sort of too concerned about that. It's basically going to be pulling straight forwards and backwards. It's not going to do too much wear. I'm not too concerned. And on the top, obviously, you've got these nice slippery slides that slides very easily with this square tubing. But as this gets to the far end, as it slides off the back, the tray is going to go on an angle. So what I'm going to do first is I need to get my long lengths of this angle and cut off the side, because I need to curve the front edge here so that when it gets to the back and it's sliding all the way off, it will stay in nice contact, and it's not going to have a sharp edge like this digging into the track. So let's cut out some side profiles and I'll show you what I'm doing.
So back over to my amazing plasma table to cut out the perfect profiles that I need, obviously so that both sides match beautifully. Then what I need to do is cut off one side of the angle so that I just have a flat plate that I can then begin to curve to the shape that I want. So now with both bits cut out, I tack the entire lengths together so I have them nice and even, and I can get them to both bend at the exact same rate. And I've got my two additional pieces that I cut out on the table, and now I'm just getting them nicely aligned and basically remaking the angle iron, but with the perfect bend in it. Now, if this was really thin, I could do this with a shrinker stretcher, but it's not quite the same thing with this very heavy steel angle iron as it would be with the really thin sheet metal. And yeah, I'm not going to have much chance of stretching this to get the perfect shape. But as you can see here, I go through and get it all exactly right and get both sides lined up beautifully so that they have the curve that I want. And once it's tacked in, then I can go through and weld the whole thing nice and solid. The whole time I'm keeping cross bracing underneath because I don't want this to warp or to change angle or anything like that. I want it to stay roughly a 90-degree piece of angle iron. Then I need to go through and grind off the tacks, and yeah, it just shows that my tacks are pretty good because it took quite a bit to actually cut these two rails apart again. Then on the other side that was trapped in between, now I go through and I just join it all together and finish it all off with a TIG, so I have a very, very nice secure piece of curved angle iron at the ends. And finish it up with a clean up with the flap disc.
All right, so we have either side rails here ready, done, and we have our kick in the end so that when they come, when the tray is all the way up, they're going to come in and sit quite nicely. And what I might actually do is I might actually raise the tray up now and sort of give you a bit of a demo of what it's going to actually function like and why I did this. All right, so if we take our rail, this is going to slide all the way down to the end of here, somewhere around like that. And as you can see, the curve is going to help with this, and my driveway slopes up, so at the moment that back end would be lower, but either way, we can slide up these. When the winch is pulling up the ramp, it will pull it up like so. And that will slide all the way up to the top, like so. And that is how my my ramp is going to work. I am very happy with that.
Alright, so with the front end of the rails done, I need to measure them out and actually cut them to length, because they are currently far longer than I need them. So again, clamping them together and cutting them together so that everything is nice and even. And then I'm actually cutting a taper underneath these, because the back edge of the tray is obviously going to need to taper down to get to the ground, and all of this will become a little bit more apparent later. Then I am tacking in some cross braces from either side to get the rails to sit where they're going to stay, and this one on the rear is obviously just a temporary measure sitting on the top.
So I have my skis on the back of the truck now, and as you can see, now this bar here is going to stay here. This is actually where we're going to attach the winch to haul the tray on and off. You can see the ends. These look like they sit up really high, but once I put the rails over the top and put the tray on, that's how they're going to sit nicely. This is just a temporary brace just to hold it together. So now I want to just lift this up and see at what point it just starts sliding by itself. It's not very heavy at the moment, but let's give it a go. Oh, let's get in movement. My battery's run out of power. And off she goes. It's slow, because as I said, it's very light at the moment, but there we go. Hey! All right, so my jump start pack is running a little low, and it's not to the full height, but you can see here I have my rails out here now going all the way down to the ground. Now, these are 400 mil shorter than where the tray is going to be, because the tray is going to sit higher than this. You'll see it once I get in, so this is actually going to be longer, and it's going to be a nice, long, easy transition to drive a car up. That's not going to be any drama at all, even on flat ground, so I am very happy with the design of that so far. All right, so we have the beginning of our sliding tray. Now, we need to do a bunch of things, and this is something that I have been thinking about for a long time, of trying to work out all of the stops involved. So obviously, if I slide this now, this is going to stab through the cab, and obviously when this is a whole tray, it's going to take the cab out. We need to be able to make a stopper so that when it's pulled up onto the tilt frame, it stops. But not only stops, we need to also lock it down to this frame, because at the moment, this can just lift up. So even with a car on it, even when it's heavy, you go over a bump, whole thing can lift up. That's not good. So we need to be able to lock this down, and that is something that I have been contemplating for a long time. The truck that I got the original idea for these slides from actually has a couple of big hooks on either end that hook over and grab hold of the end of the tray itself and lock it on. But you see these big ugly hooks, and I mean, in that one it's got like a big frame out here. I don't want to have any of that. I want to try and keep this looking like just a flat top old truck without necessarily having any headboard on it if I can avoid it. Now, I don't want to see these hooks. And what I'm looking at is I'm thinking I am actually going to use this crossbar here. This is going to be my stopper, and I'm going to get some lower angle in sections on either side, all reinforced, and it's going to, this will be attached to the side rails. So as it comes in, it will slide up, hit this, it will stop the forward movement, but also it's going to lock it into this tilting frame. Now there's going to be other locks out on the sides afterwards from the tray locking it to the actual chassis of the truck, avoiding, you know, basically clamping the whole thing down, including the tilting tray. That's got to come as well. But yeah, lots of sleepless nights, just waking up in the night and my head's going over different versions of how I make all this, because obviously I've got clearance issues. There's also a stop I need for the back. There's lots of other things to do. So it's not just making one end. I need to lock it on the back, and also I need to stop it from sliding off the end when I lower it. So let's start working through this. I'm just going to start trying to design little brackets, etc., and see what I come up with. But I can already see that the thing I did only yesterday, mounting this control box, it's in the wrong spot. So that's going to come off, and we'll worry about mounting that later. And for now, let's start looking at what we need to do to make some stoppers up here.
So like I said, I've had some basic ideas in my head for quite some time, but sometimes it's just a matter of getting out there and trying to build it. So you can see here I'm starting with just some cardboard just to get my head around what I want to actually build and design. And once I've sort of sketched up something, I've got a bit of an idea, I've gone into CAD, and this is roughly what I've come up with. So it probably doesn't make a lot of sense right now, but let's take it to the plasma table and cut it all out. And there's a fair bit of time just setting all the machine up and using all of these bits, but I'm trying to use up as much scrap as I can, you know, be as frugal with my steel as I possibly can. Then using the air hammer, I knock the bulk of the dross from the plasma off, and then just go around and clean up every piece with the flat disc on the angle grinder. Using my handy dandy world class 90-degree magnets, I can go through and start welding this all together and making some nice solid mounts. I particularly like the TIG for this sort of delicate work. It makes a lot cleaner job of this stuff than the MIG, which adds a lot of material. And with those done, I need to cut out the little bits of angle. So these are actually going to be the pieces that interface and actually provide the face of my locks. Then clean off the paint on the sides and tack on my new brackets. And these brackets have been sprayed inside with some weld through primer, and once I'm happy with the location, I can weld them all in solid, including all of these top braces. And I realized afterwards I've massively over-engineered these things. They are much more stout than I needed, but better to be safe than sorry. The little bits of reinforcement aren't going to add that much weight.
All right, so we have these braces on. I'm looking at them now. I massively over-engineered this because this doesn't need to be that strong at all, particularly lifting up. This is only really going to be locking it in when the tray is tilting. When the tray is down, it's going to be locked in separately, so that's not a big deal. But yeah, that is now good. I can slide this up, and yeah, it locks in nice and solidly. So that is going to bottom out. And yeah, I've got plenty of room at the end for the tray, so that should be good. So now I need to make the mount for the hook.
So back over to the plasma table, and this time I'm using some really heavy duty 6mm stock. Then I need to mark the dead center of this angle bracket. Now, this is going to have a lot more reinforcing later.
All right, so I've got my little hook. It's just tacked on for the time being. I can get my winch, connect that up. Now let's try and lift this up and see if this all does what it's supposed to do. How good is that? Yes! That works so well. Holy moly. All right, that works really well. I have it all connected up. Shouldn't touch the remote while I'm talking. I have it all wired up to the 24 volts. So this is the first time I've actually used the hydraulic ram with 24 volts. I've always been using it with a 12 volt jumper pack. Works so much better that way. The slide, everything is working the way it is supposed to, which is fantastic. So I'm just going to unwind that cable. Like I mentioned, I'm going to replace it with some Dyneema rope. It's already ordered, but I'm going to drag this out to its full extent now and just see how it sits when it's all the way out, and then pull it all the way back in just the way it was intended. Yeah! All right, so you can see here how low that is with the ramp at full height. That is going to be really good. Now, this is obviously, this slopes upwards, so there's going to be a little bit more angle than that, but this is also going to have an extra 400 mil length. I am very, very happy with that. So let's connect up the winch now and winch the whole thing back on again. Yes, that works fantastically. Yes.
Oh, I know it's just a simple cycling of things, and it's not that complicated of what I've done so far, but oh, it feels so good to have finally gotten to this stage. So I reinforce in the little eyelet for the winch, and now I need to start cutting up a couple of the rails that are actually going to be the base of the bed for the truck, because I need something welded on either end to start giving this some of the structure. Now for the width, these rails are actually 1.9 meters wide, so that's going to be the width of the center, and then you've got 50 mil either side for the side rails.
All right, so we have the first rails on now. So these are going to be every 400 mil all the way along, and then we'll have the tray on top of them. So these are the structure of the actual frame. So I just put one front and rear to start with. They'll basically be the guides to sort of straighten and square everything up. But so far we've got all of this front end done with the locks and the pulling ring. So down the back we need to now make the rear locks. Now I'm thinking I'm going to do similar to what I did at the front.
So now I have the first of the rails on. I can cut off this temporary brace because that is the piece I need to make the start of the rear locks, and then going through again and pretty much the same thing as what I made on the front, but these are going to sit slightly lower than the front locks so that the front lock doesn't catch it as it's going over the top, and that will make more sense later.
All right, so I've had a bit of a think. A lot of this week is just having a think and then trying to put things together and just see how it all comes out. It's quite a difficult thing to come up with all of these bits and pieces and how it's all going to work. And I've sort of been coming up with it in my head for weeks. I often wake up in the night and work out exactly how I'm going to do these locks, etc. And I think it's coming together quite nicely. I'm working out now that I think I'm going to cut this little triangulation bracket, just cut the end of it off, and I'll actually tie into that. And this is going to sit in here and have the angle on the edge of it. That will be able to catch my rear locks with the front lock still being able to slide over the top without interfering. So I think that'll work quite nicely. But I am out of time this week, in which case I think it's time for Fun Facts with Mrs. Jeff.
Hey guys, In late 1965, 2 experimental all-aluminium GT40 chassis were manufactured in England by Abbey Panels. One of the tubs was shipped back to Dearborn for testing, never to be seen again, while the other one was shipped to McLaren. The chassis shipped to McLaren became a lightweight, open-top version of the big block 7-litre GT40. Most of the steel chassis GT40s weighed around 1,300 kilos. McLaren's goal was to reduce that weight by around a third. Howden Gainey at McLaren considered every component of the GT40 and gave it a well-considered diet. With the aluminium chassis fitted with a lighter Hewland gearbox, he got the overall weight down to around 860 kilos. Unfortunately, the X1 proved unreliable and it was an unsuccessful season for it in 1965. From there, the X1 was sent to Shelby American, where it was heavily modified and used for testing new components. Its final race was at Sebring in 1966, with Ken Miles and Lloyd Ruby taking overall victory. Unfortunately, it came to a sad end because, due to a temporary import bond on the car, the owner chose to scrap it rather than pay the taxes and fees.
All right, we actually have a bed that's now tipping and sliding. It's getting there. There are lots of these little components that take a lot of time. Like I said, I keep waking up in the middle of the night, coming up with the solutions and sort of thinking through all the problems and all the different ways I can do these things. And I think we're getting there. So it's getting very close now, and I'm enjoying the process.
Fateful words, Jeff. Whenever you say that, I feel like, anyway, we'll see.
It takes as long as it takes.
It sure does. Like and subscribe and let Jeff know what you think on his videos. He likes to read your comments. And of course, Patreon, if you want to help him out in this majestical journey. And see the videos a day early if no ads.
All right, guys.
Bye, guys.
See ya.
Howden Gainey at McLaren considered every component of the GT40 and gave it a diet. Unfortunately, the X1 proved unreliable, and from there, the X1 was sent to Shelby American, where it was heavily modified and used for testing